हेलो स्टूडेंट्स, आज मैं आपके लिए लाया हूँ जेई एडवांस 2018 का प्रॉब्लम ऑन फंक्शंस। आइए देखते हैं इस प्रॉब्लम को। लेट फंक्शन फ्रॉम रियल टू रियल एंड जी फ्रॉम रियल टू रियल विद टू नॉन कांस्टेंट डिफरेंशिएबल फंक्शंस। तो एक तो नॉन कांस्टेंट है एंड देन इट इज डिफरेंशिएबल, व्हिच मींस फंक्शन एक्स एंड जी एक्स आर definitely going to be differentiable and as well as continuous. So if f of f dash of x is equal to e to the power f of x minus g of x multiplied by g dash of x for all x belong to R, and g and f of 1 is equal to g of 2 is equal to 1, then which of the following statements is are true? So it is asking that the value of f of 2 has to be less than 1 minus ln 2, or it has to be greater than 1 minus ln 2, and same way whether g of 1 is greater than 1 minus ln 2 or whether it's less than 1 minus ln 2. सो आइए देखते हैं इसको कैसे सॉल्व करते हैं। सो फर्स्ट इस इक्वेशन को सिंप्लीफाई करते हैं हम लोग। तो यहाँ से एफ डैश एक्स और इसको जी डैश एक्स को इधर ले आते हैं। सो एफ डैश एक्स बाई जी डैश एक्स will become equal to e to the power f of x divided by e to the power g of x. Now I can bring e to the power f of x on one side and send this g dash x on the other side, basically to bring all f of x um, uh, variables on one side, or the entire f function on one side of the equation and g of x function on the other side of the equation. So the moment I do that, it will become f dash x by e to the power f of x is equal to g dash x by e to the power g dash x. Now let's see how to integrate it. So we are seeing here e to the 1 by e to the power f of x into d of fx by dx, which is f dash x, and this side also e to the 1 by e to the power g of x into d of g of x by dx, which is nothing but g dash x. So now again further, dx cancels from both the sides. We are left with e to the power minus f of x, d of f of x is equal to e to the power minus g of x, d of g of x. So अभी ये g of x f of x लिखने में it will take more time. So I'm just assuming that let's call f of x as p and g of x as q. So I will just substitute those here and try to integrate both sides of the equation. So integration e to the power minus of p dp, because f of x is replaced by p, and again here we are having f of x, so that will become dp is equal to integral from e to the power minus q dq. G of x is q, and then again we have d of g of x, which will become dq, plus some constant of integration c. So now if I integrate it, it will become simply e minus of e to the power minus p is equal to minus of e to the power minus q plus constant of integration. Now sending minus e to the power minus q on the left hand side, it will become e to the power minus q minus e to the power minus p is equal to c. And now I bring back g of x and f of x. So I will replace q with the g of x and p with f of x, and therefore I will get this equation. Now after this I can start substituting, because it's showing that e to the power minus g of x is equal to minus e to the power minus of f of x is always a constant. So I can take this value one at x equal 2 and one at x equal 1, and they both must be same. So that means e to the power minus g of 2 minus e to the power minus f of 2 must equal e to the power minus g of 1 minus e to the power minus f of 1. So what we are seeing on the right hand side is basically the value of this entire function e to the power minus g of x minus e to the power minus f of x at x equal 1, and same thing on the left hand side, we are seeing the value of the function at x equal 2. So these two must be equal. Now we will do a little bit substitutions, because we know that certain values are known to us, like we know f of 1, which is given as 1, we know g of 2, which is given as 1, so it will become e to the power minus 1 minus e to the power minus of f of 2, we don't know f of 2 as of now, is equal to e to the power minus g of 1, that also we don't know, minus e to the power minus of 1, because f of 1 is given as 1. So now I will just bring e to the power minus 1, and I will collect all the constants on one side, and then e to the power g of 1 and e to the power f of 2 on the one side. So it will become 1 by e to the power g of 1 plus 1 by e to the power f of 2 is equal to basically 2 by e. So we are done up till here. Now it's now here, from here actually we have to see like how we can go to the uh, options that are given to us. So we can see here that I can write 1 by e to the power g of 1 equal to 2 by e minus 1 by e to the power f of 2. Now, if we all know that e to the power minus g of 1, right, always need to be a positive number. So it has to be greater than 0, because exponential function, whether it's a positive power or a negative power of an exponential function, the value has to be greater than 0. So therefore, this entity on the left hand side, 1 by e to the power g of 1, must be greater than 0. And therefore, what we are getting on the right hand side, which is nothing but the value of 2 by e minus 1 by e to the power f of 2, which turns out to be 2 e to the power f of 2 minus e by e to the power f of 2 plus 1. This value must be greater than 0. So therefore, that's what has been done. So we'll put e to the power f of 2 plus 1 by 2 e to the power f of 2 minus 1 minus e greater than 0. And now again, we know that the numerator over here, e to the power f of 2 plus 1, is greater than 0, always greater than 0. Therefore, the denominator also must be greater than 0 for this entire ratio to be greater than 0. So 2 e to the power f of 2 minus e should also be greater than 0. And if that happens, then basically 2 e to the power f of 2 should be greater than e, and taking the log natural log on both the sides, it will become ln of 2 plus ln of f of, plus f of 2 greater than 1. So that means it will become f of 2 greater than 1 minus ln 2. So this was one of the options that that was given, and we have got that f of 2 is actually greater than 1 minus ln of 2. We can do the same kind of thing this time uh, by keeping 1 by e to the power f of 2 on the left hand side and sending e to the power g of 1 on the other side. So we'll put 1 by e to the power f of 2 is equal to 2 by e minus 1 by e to the power g of 1. And then again the logic is the same. We will kind of try to find the value of this, take the reciprocal. So it will be e to the power f of 2 is equal to e to the power g of 1 plus 1 by 2 e to the power g of 1 minus e. And we know that e to the power f of 2 must be greater than 0, whether f of 2 is positive or negative number for any real number. It's given in the question that it is belonging to real. So for any real number, we know this is going to be positive. So we are putting this entire thing greater than 0. Again, we know e to the power g of 1 plus 1, which is the numerator, has to be is always greater than 0. So the denominator also need to be greater than 0. And then we will land up to the same kind of equation, like 2 e to the power g of 1 has minus e, which is the denominator, is greater than 0, which means 2 e to the power g of 1 is greater than e. And putting the taking the natural log on both the side, ln of 2 plus g of 1 is greater than 1. So which means that g of 1 is greater than 1 minus l2 1 minus 1 minus ln of 2. Pardon me here, it's not, this is not correct. It is 1 minus ln of 2. So therefore, we are seeing that we are having the options B and C, which are the correct options for us. If we go over here, so the option B is telling f of 2 is greater than 1 minus ln of 2, and same way option C, which is g of 1 greater than 1 minus ln of 2. So these two are the correct options that we have. So hope you enjoyed this problem. This problem was not a very hard problem. It was quite simple, just needed some kind of manipulations and some kind of simplifications of the equation, little bit of integration. So not a very difficult problem, I would say. So hope you enjoyed it and helped in understanding of this problem. And I will be coming up with more such videos around JEE Advanced problems. So stay tuned to our channel. Please like, subscribe our channel. Keep enjoying, keep learning. Have a great day. Thank you.